In this lecture, let's talk about how to graph a polar equation by using a TI-83 calculator. And you see, here is the polar equation. R equals cosine theta times cotangent theta. How we are going to graph that? We have seen that graph this without using the calculator, but since we have the calculator, why not just use it? Here are the steps. First of all, you want to do is you want to check the mode. Okay, so in the mode, you want to do two things. One is when you click on mode, you want to check as radian is highlighted. You see the radian, the third row, this one is highlighted. That's fine. But the second one you want to see is the polar should be highlighted. You see this one, POL, is not highlighted. So you want to do is move your cursor to the polar and hit the enter. Okay, once you move the cursor to other places, you will see polar is highlighted. Okay, that's the first thing. In mode, you want to do two things. Alright. Now, you go back. You go back is to input the equation. Now you hit y equals this time. You see you already have the R1. R1 means the first equation. Actually, you can put any polar equations right here. Cosine theta we can put in, so you do cosine, hit this number, this key, but we don't have a tangent, so you want to do, we don't have cotangent, so you want to do is cosine theta, cotangent is the reciprocal of tangent, so you may say divided by tangent theta, okay? That's important. So divided. And then you put tangent theta, close parenthesis. And now you can do is to then graph it, okay? So graph the equation. You hit the graph, it gives you the graph. Yeah, but you have no idea how does it look like. Okay. Now, you want to zoom in. Click on zoom, and then second. Okay. Oh, you may say it didn't work. Remember, hit enter. And it shows up. Okay. Now you may say there is a horizontal line right here. Horizontal line is really not the part of the picture. Is asymptote. Okay, it's asymptote right down here. The real graph is those two branches. You may try a few points. Here, I did 2 points. You may try a different point by doing what? You see, second table. Okay, let me clear those things. Let me clear this. Yeah, let me re-input. You want to input theta, that's the pi over 6. Then you should have a 1.5. So you do second pi divided by 6. You hit enter, it gives you 1.5. So pi over 6 is 30 degrees, and 1.5 is the radians. So it reaches here. Huh? Okay. Now, you may do 5 pi over 6 also. So you may do 5 second pi divided by 6. That's basically what? 150 degrees. Okay? 150 degrees. And then you will get another 1.5. See? Yeah, 1.5. Alright? And this one is the 60 degrees, and the radians you may find out. You see, 60 degrees is what? Second pi divided by 3. Because 180 degrees is pi divided by 3. You have a 60. You hit enter. It's very small, huh? Okay? Yeah. So then you have a 2.9, or let's say roughly 0.3 is the radians, and 60 degrees is the angle. Okay? So this is one point. Another point is right here. That's why the graph goes like that. Okay? Now you can graph it. You see, go back there. Graph. That's the graph. You zoom in, you get that. Okay? So basically, this is the step that we are going to follow, and then we can get the graph of the function in polar coordinate. Here, make sure you know how high is this. This is actually 1, huh? Okay, 1. Yeah, this is basically y equals 1. How can you be sure? You know, this is the way. Let me show you how algebraically you can convince yourself. Okay, there are few ways you can convince yourself. Look, here is the note. R equals cosine theta. Cotangent is cosine theta over sine. That's not a problem. And then you know both sides times sine what you get down here is R sine theta. Right hand side is cosine theta squared. Now, look, R sine theta is y, huh? Okay, and then cosine theta squared is positive. That's why, you know, again, cosine theta squared is positive. It tells that y all the time is positive, okay, including 0. And then what? And cosine theta squared, you know, is less than or equal to 1. Okay? Yeah, like that. Like that. So, basically it tells us y is in between this band. Okay? So that's why we have a picture looks like that. Alright? Please review this lecture. I'll see you next time.